Okay, so we'll talk about the relation between pointers and arrays. So we have a constant integer name size, and then we simply create an initializer list to give us an array, right, of 3 elements. And we come back over here. Actually, let me copy this. And okay, so we have 3, 4, 1, 10 size. And then we have that block of memory. Okay, so we've been taught that that we can reference 0, 1, and 2 to refer to each element in an array. So, but how does it how does it know to go from 96 to 92 to 88? Like how does our compiler know? So it knows because behind the scenes they have built in so obviously they have the starting point 96 and then the memory offset. How is it calculated? Well, it depends on the data size. In this case, an integer is 4 bytes. So it is at address x96. So the offset is 0 times 4, 0. So when we say give me the element at 0, then it gives us the element at address 96. And if we go to element 1, then it's 1 times 4, so 96 minus 2. Offset is 4, so then it knows to jump to address 92. And if we go to the second index, then it's 2 times 4, 8, so 96 minus 8, and 88, right? So that's what's going on behind the scenes, and that's how that works behind the scenes. So needless to say, right, like we're more familiar with numbers, right, sequential numbers like 0, 1, 2, and what have you, and that's why that's been abstracted away from us. The memory offset, it's been abstracted away from us, so we don't have to deal with that. You will have to deal with that like when you take assembly language, right? So then you'll get more into the CPU and how those registers work. But here, like, it's behind the scenes. We don't have to think about it. But I just wanted to make sure that I make you aware of this. So if we come back here, and we execute this program. Which one is it? 4. Okay. I think yeah, number 4. And we execute this piece. Okay, I was getting lost there with all that text. Okay, so initial array address, and it displays an address for us. So ff00 ending address. So as we can see, the name of the array is, we display it, it displays an address. If we do the same with size, then we know we're not going to get an address, or at least we should be expecting that. We run it again. And we get the number 3. We know that if we want an address, then we have to use the ampersand. Once we do that, then it gives us an address, which means what? The name of an array is a pointer, right? So the name of the array is a pointer. It's pointing to an address. So it's important to understand the difference, right? So this is just a simple number. It's not in an array. It's just a simple variable, and this is an integer array variable. So notice the difference, right? So make sure we understand that. So having learned that, what can we do? So can we let me see here. This is a pointer. We can point to it, right? So sorry, and we can say, okay, let me create a pointer to numbers and numbers, right? So now I'm pointing to numbers, and now I can do what I wanted to do. I can say pointers plus plus, but before that, what the heck is pointer, right? So let me display that. Value at pointer, and remember, with a pointer, if we want the value, then we use that. We dereference the pointer, right? So then we do that, and then we'll say plus plus, and then we'll do it one more time to see what we get. Okay, so let's go ahead and run this piece of code. So 4, 1, 4, and 1. Okay, let me put a new line here to make it clear, and then we execute it one more time. So we point to the array, we display the value that it points to, and then we say pointer plus plus without dereferencing it, and then it moves to the next address, and then we can display the next address, which is it's pointing to the first element. It's pointing to this element. We do pointer plus plus, now it's pointing to that element. And if we go ahead and do it one more time, then we would expect it to display the number 10. And it does, right? Let's put that new line character. So down here, so value 10, so 4, 1, 0. So what if we say pointer minus minus, and then display again, run in terminal. I keep on forgetting that new line character. Okay. I'll copy this one. So notice now it's number 1, so it's going backwards, right? So then if we do pointer minus minus again, and then we would expect to see the number 4. So 4, 1, 10, 1, 4, right? So any questions here? That's the relation between the pointer and an array, right? So an array points to the first element, and then in this case it's up to us to know the bounds, right? Like to know that this is the first element and this is the last element, because an array doesn't know its size. We have to keep track of that. We have to keep track of the size. A vector knows its array only because code like this, well, similar to this, not quite like this, is in the class. And if we're just kind of thinking, well, how does that work? Okay, so there must be a list variable, an array variable in the vector class, and then there's another variable, size, and that's why when we say vector name dot get dot size, it reads that size variable and returns the size of that vector to us. So in essence, with a class, we make the vector know its size. So programmers had to write a lot of code to make that happen, right? So it's self-contained. Yeah, so for an array, you don't need the ampersand because the name of an array is pointing to the element's address, the first element's address. For simple numbers, then we do need an ampersand to get the address. Yep. So any questions here? Okay, so no questions. Okay, I'm gonna create 2 examples. So array function arguments, and then we will see how that works, and then we will go with another example that's similar, but instead of using the first syntax, we'll use a pointer to pass in an array as a function argument. So that's what we'll do. Pointers, array, and functions. Okay, so we come here, number 5. So I iterate an array, and we will say numbers, and we pass in the size. Oh, let me copy this. This is a header. Okay, we copy the code to the CPP, IOStream. Okay. Let me do one thing here. Let me move IOStream to the header. That way I don't have to include it a lot of times all over the place. Okay. So we have a function iterate array, nums, and we pass in the size. We have to pass in the size because the array doesn't know its size. So integer equals 0, I less than nums of I plus plus I and then we simply see out the number. What am I doing here? Sorry, is that my son's brother or my ex's son tested positive COVID, so now I'm worried about my son. So sorry. Okay, so see out sums y and then \n. Okay, and size. Okay, so in main we will include array functions, and I guess we can leave that one here, and this is the incorrect main. Okay, so this one is not the main that I'm seeking, it's this one. Okay, so we'll say iterate array, and we need to create an array, so we'll say okay const, well, maybe I do need that code. I'll just copy this code, prevent retyping. Okay, so I come here, I create an array, and then I'm like, okay, let me pass numbers and let me pass size into that function, and let's execute this program. So we come here, array functions, and we go ahead and execute this program. Okay, so we have a 4, 1, and 10, right? So let's look at the syntax again. So we come into the functions CPP, and we have the header. So iterate array, we have a parameter with a subscript operator, right? So the data type for the array, the name of the array in this scope, and then the subscript operator and the size. Like, we have to pass in the size because the array doesn't know how to how big it is, right? So one thing I want to do here, we're saying iterate, but one question I'll ask: this parameter pass by value or pass by reference, from what we've learned so far in the previous example? As you remember, in the previous example, the name of the array is a pointer, and we know that a pointer by definition points to an address. So what do you all think? Okay, so what we will do is we'll create a test case to test that. Let me see here. It can be both. Okay, so let's see here. Test examples module 10. Let's do module 10. Include I think that's the name of it, but I have to come in here and configure all projects to make that available. Okay, so we come here, test case, test array function parameter value or reference parameter, test if. Okay, so come back here and we'll copy this code and put it in this test case. But in this function here, we'll write some code to modify one value. We'll modify just one value, and we'll wait for it to exit, right? So then we'll say the nums at size -1, or the last element, we'll set it equal to some large value. Oops, lowercase. And we come back to the test case. So now we can say, after the function executes, we can say we require that the numbers at size -1 equals 10 or 1000. Those are our two options. What do you all think? So now we know that it can be both, right? So it's either one or the other. So is it 1000 or is it 10? We have one for reference and one vote for, I think it can be both. So then can you go back to the other screen? Okay, to this screen. And then we'll try 1000. And then we'll see what happens, right? So I think it's catching up. That should be okay. Oh, size is uppercase. Okay, so then we can go ahead and execute this test case. Run, and let's see. And it's still building. So we have 2 for 1000. So one reference and one 1000, right? So that's the same thing. Okay, take your time here. Linking. And green, we know, is good. Up arrow space dash s, lowercase s, caps locks. Okay, and it is, right? So the answer is it's passed by reference, right? So an array is passed by reference, and if we think about it, well, I mean, if the name of the array is a pointer to where the array starts, and then we're passing in the actual array address, right? Hypothetically, this address. So we are working with these 3 address blocks. Actually, that's 96. So it's what, 96? 12 address blocks, right? But in 4-byte chunks. Okay, so any questions here? So we have to be careful, right? And if we know that this is by reference, then we can protect our code by passing it in as const reference. If we didn't want someone to modify it, then we could do that, right? We could protect it. Okay, so that was the first example of using an array and passing it into a function. And we will go into the next example. And it's the same, almost the same signature, but we'll change the name to pointer here. And we'll say that we are passing in a pointer to nums. So we're passing in a pointer to nums, and I renamed it, okay? Array functions here. And then, well, first we execute that piece of code. We'll come back to main. In here, we will say, is this the correct main? Array functions, yep. Pointer. So we pass in numbers and we pass in size. Right, so, and then we come back here and we run the SRC example, not the test case. We just want to see what it displays. 4, 1, and 10. And let's go back and look at the signature again. So notice we're passing in a pointer, and up here we're passing in with array syntax. But as we can see, so far they work the same. If we come back to CPP and we do the same thing, modify the last element, and we go into our test case, and we'll copy this code and we'll say pointer array, and this one is PTR, and let's run our test case. Let's see what happens. What do y'all think will happen here? Will it be 10 or 1000? So run in terminal. And 10. So 2 for 10. It's building. So what is a pointer? So a pointer points to an address. Which address in this case? The pointer address. So would it differ? I mean, does it matter that this is a pointer and this is an array syntax? Green, up arrow, space, -s, enter. So it's still 1000, meaning it's also passed by reference, right? So we come here. So notice this is the number 10. In the function, we purposely modify the last element from 10 to 1000. We call the function, and afterward we test the last element. So it's 1000, meaning it passed by reference, and it should pass by reference. Like, let me see here. Yeah, so if you recall this example, that's when we showed that if you pass by pointer, then you can modify the value. So this was 09. So it was originally 10, and then in the function we modify it to 200, and it's modified. So a pointer passes the address, and it can be modified. So that's important to know, right? So if you pass by pointer, you're passing the original address. So it's, in essence, you're passing by reference, and that should have rung a bell, right? Because remember, a pointer works like a reference. It just has more functionality. a reference points to an address, a pointer points to an address. So with that in mind, then we should have been like, oh yeah, it should change it to 1,000 because it's pointing to the original address location. So questions here, like why that happens? Okay, so no questions. Okay, so now let's see. Let me see here. So function parameters, I covered that. Okay, so now we will talk about two-dimensional arrays, and we will use the same array functions header. So we want to create a two-dimensional array, but before we do that, like, what is a two-dimensional array? Okay, so we come here and we talked about that one. Two-dimensional array. Okay, so what is a two-dimensional array? So for our tic-tac example, we had a simple list. 1, 2, 3, 4, 5, 6, 7, 8. 0, 1, 2, 3, 4, 5, 6, 7, 8. 9 locations, right? 9 locations. Any of those could be X or unmarked with a space. It's a one-dimensional array. And that's how it looks in memory, like sequential. How does the two-dimensional array look in memory? Look like in memory, right? So if you have photographic memory, then you would know with that image, right? But let's work on the tic-tac-toe if it was a two-dimensional array. So maybe let me two-dimensional array, and then we have row 0, 1, 2, and then we have column 0, 1, 2. And then we have the stack. And we have row 0, column 0, this one, row 0, column 1, this one, row 0, column 2, this one, row 1, column 0, this one, 1, 1, this one, 1, 2, this one, 2, 0, I mean 1, 2 was this one, sorry, and then 2, 2, 0, this one, 2, 1, and finally 2, 2. So the question is, how is the memory offset calculated? Don't have it memorized, but it's here. So row times number of columns plus columns times the data size. Okay, so Okay, so let's put that here and then let's test it. Okay, so we're saying let's find this guy, and well, let's put some addresses here. So X, so we'll say 96, 92, 88, 84. Let me see, 196, 92, 88, 84. Is that correct? Yeah. 80, 76, 72, 68. Let's see if we can calculate that one. So row 2 times number of columns, 1, 2, 3, 3, plus the column we're seeking column 1, times data type size. By now we know that an integer is 4 bytes. So 2 times 3, 6 plus 1, 7, times 4, 28. 100 minus 28, 72. Address 72, right? So that's how C++ and most programming languages determine how to find elements behind the scenes as we're iterating with loops, as we're iterating the array, right? So interesting, right? So if we wanted to find 0, 0, row 0 times 3, 0 plus column 0, 0 times 4, 0, so 0, 0, and we would get at the address 100 minus 0, 100, so we would be dealing with the first element, right? So questions there? And that's how we would calculate memory offset for a two-dimensional array. And how do we create a two-dimensional array? So let's go to that example. And what do we do here? We'll come here and array functions. We will create two functions. One to add values to the array. What kind of array? A times table, right? So we'll say void populate times table, and we'll say integer calls, which does not exist yet, and then we will say rows, which is a parameter. So we have to this is a header, right? So let me get rid of that. We have to fix this. And well, maybe if we say, well, I want a const integer call or calls of 10, const integer rows of 10. Okay. So now we have the columns there. We copy the signature or the header, come back over here, and then we can say, okay, let me write some code here. And we'll stop there. We come back to main, and we will say int times, we'll come back and write the code, okay? Times table of rows and columns. So notice I included the header, and that's how it knows that rows is 10 and that columns is 10. If you look at the book example, it puts the values here. Which values? These values. But I mean, really, they belong to the functions header, right? So that's why I put it in the header. They belong to this unit, the array functions H and CPP. So that's why I prefer to put them there myself. So, and for now, we will simply not initialize anything. So we will say populate times table parameter, and then rows parameter. Technically, we didn't have to do this, but we want to shy away from the use of global variables. In this case, we're forced to. Like, we have to pass in this syntax, and we have to include the number of columns. Like, otherwise, we'll get a syntax error. But so that's out of our control. But this is still in our control, so that's why we pass it like that. Okay, questions so far? No questions. Okay. CPP. So how do we iterate this guy? So we can say for integer I equals 0, I less than rows, increment I, and then another loop. So we do a nested loop for integer j equals 0, j less than columns, increment j. And then what are we trying to do? We're trying to populate the times table, meaning we want to add values for 1 times 1, 1 times 2, 2 times 1, blah, blah, all the way to 10 times 10. So that's what we're after here. So it would be helpful if this parameter had a name for the variable. So there we go. So we have a times table at I j equals I plus 1 times j plus 1. And just to stay consistent with how we coded in this class, we will also do this. Notice that it doesn't give us an error, meaning, oh, it's not really required. No, it's not really required, but it's always good practice to put the names of the variables here so that we can remember in the future what we're doing, right? We just don't depend on the name of the function. Okay, so that's the required syntax in C++. So that's what we have to do then. Okay, how is this gonna work? Okay, so let's look at our diagram. Okay, and let me I j. Okay, so let's look at the code here. For integer I equals 0, I less than rows. Okay, so first iteration is I less than 10. Yes. Comes in here is j less than columns. Yes, right. So both of them are 0. So the element at I0 and J0, I0, J0, so this element, assign it the value I plus 1, 0 plus 1, 1 times j plus 1, 0 plus 1. So the value of 1 times 1. 1. Okay. And then loops again, j is 1 less than 10. Yes. Okay, so then the value at I0 and J1, this one right here, assign the value 1, right? Because I is 0, so 0 plus 1 1 times j1, so 1 plus 1, so 1 times 2, 2. And then we'll do one more. Actually, we'll do 2 more, right? So comes around, j is 2, I is still 0, so 1 times 2 plus 1, 3. All the way to 9, but we're not going to do all 9, right? So then it comes here and loops. J is 3, J is 4, J is 5, J is 6, J is 7, J is 9, J is 10, and then it stops looping, comes over here, I is 0, is I less than rows? Yes, so increment I plus 1, so now I is 1. So I is 1, J is back to 0, so I is 1, J is 0, I is 1, J is 0, so this element, we're going to calculate the value for that one. So 1 plus 1, 2, times 0 plus 1, right, because J is 0, 2. So then, oops, the value would be 2 here. And then we come back, and is 1, J is 0, comes over here, so now J increment by 1, so J is now 1. So the value at 1, 1, I1, J1, this value, and that's the last one we'll do, right? So 2 times 2, fourth, and so forth and so forth, right? So that's how that is working. Any questions on how this nested loop is working? No questions? Okay, so then we'll go ahead and write the other function, which is to display the times table. So display times table. We will need IOStream, but we also need input-output manipulation. That's IO-manip. So we'll need that one to display nice columns. Come back over here, format columns, right? So and we'll use more or less the same code, but now we are not assigning. We will say cout, and then we will also say set the width of each entry to 5. After the row, let's create a new line. Okay. And then we come back to main. So we populate the times table, and then we want to display the times table. And we need some parameters, so times table, rows, and that should be good. And we'll come here and we run in terminal. and there we go, right? So we have our times table right there. Well, it's there, right? So everything's there, right? So any questions on this? So this is a 2-dimensional array, and we just do something simple, right? Just create a times table in the populate times table, we simply iterate every single element and we multiply numbers to create our times table. In the display times table function, we iterate the loop, nested loop, go through every single element and display one row. So it comes in here, displays one row, and then after that row displays, then we create a new line, comes back over here to display the second row, and that's how it goes. Questions? Okay, no questions. So then we jump over to, so this was two-dimensional array. The book has an example for three-dimensional array, but I think that's probably too much for now. So, and you're not gonna need that anytime soon. So, but the example is there. So now I want to jump back to the shapes example, and we will create an array of objects. So 6. Main, we'll work in main. So okay, so good. So I had talked about pointer to objects, but now we will create an array of objects. So I don't think we need this for now. I'll remove the comments before I check in. So we say, okay, so I want to create circles size, so an array of 3 circles, and then we can say, okay, circles at position 0 draw, and position 1, and finally position 2. And we can execute this code. Let me come here, run in terminal. So draw circle, draw circle, draw circle. So with this we created an array of objects, and they are still on the stack. We didn't create any dynamic memory, okay? They are still just this one. So we come here, and it's important to understand that we created that array on the stack. So that's size 3, and then we would have like a chunk of memory. For now, we'll assume that it needs 2 chunks of memory for each object. So this is on the stack. We still have the heap available, but it's not in use. And this one goes here, points to the first one, and then it points to all of them as a big chunk. And this would be C1, C2, and C3, right? Circle 1, circle 2, and circle 3. So 3 circles. And that's how that would look. Okay. Any questions so far? I thought it was going to vertically. Well, it does both, right? 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. So. And that's Adrian's question. Okay, and that's how we would work with a list of objects on the stack. But remember, the stack is always limited memory. So if we stick to this convention and then we have to read in a lot of records, this strategy is not going to work. We'll run out of stack memory. So we need to we need another method, and that method is to create these objects on the heap, because we know the heap is larger, 2 to 4 gigs, right? Depending on OS operating system. So if you recall from let me see, was it this one or this one? No, I think it was pointers. Well, I don't have the example there, but we need to create dynamic memory. With dynamic memory, we use the keyword new, and that's the easy part. We have to make sure that we create memory, use memory, release memory. Simple concept, but it's not as easy as it sounds. So C++ recommends that we create dynamic memory in a limited scope, meaning like in a function, and we create the memory, use the memory, release the memory before we leave that function. Simple concept, but it's not. And the other alternative we have is to create dynamic memory in a class, and the class has a larger scope than a function, right? Because it can have one or more class functions. So we create dynamic memory in the constructor, and then we use the memory in the class functions. And then I did post that message over the weekend. I completely forgot about the destructor, right, for the homework. Destructor executes one time when the class is removed from memory. So if we create memory in the constructor and then we delete memory in the destructor, when that class is removed from memory, before it's gone, it calls the destructor, and that's when we delete memory so that we don't have any memory leaks, right? So that's the example we'll start working on Wednesday. Okay, so for now, we'll say, okay, so this is an example for stack memory. We want one for dynamic memory. So we will say, okay, so we need a pointer to shape. So a pointer to shape, and shapes equals new circle of size. But notice we're locked in. Like here we're locked in. It's kind of like, oh, I thought you said shapes. But we're kind of locked in for now, like kind of like, oh, I have to create all circles. And then we can say shapes arrow operator draw need subscript here, so shapes at 0, shapes at 1, actually this is dot and this is dot, and finally 2. So now we should have 1, 2, 3, 4, 5, 6 draw lines. Before we do that, let's get this, come back over here, and put it here. Assume the size exists already right now. Okay, so we come here. Okay, so let me go ahead and bring in the other, this guy. Okay, so 3, and this one is this one. This one points here, and then we'll have I'll just make up some here. say first circle's here, second circle's here, and the third circle's here. So that would be pointing to that address, meaning that, say, this is Y something, so Y70. So notice now we moved the objects to the heap. So now we have more memory to work with more objects, right? We don't have to worry about running out of memory as fast as if we would create objects here on the stack. So that's how this looks. So, but we're kind of stuck. We're like, hey, wait a minute, I'm just working with circles here. Like, what if I want to work with different types, right? Which is really what we want. So then, what time is it? 6:47, 13 minutes. Yeah, we have time. Okay, but before I do that, so then we're like shapes, and then it's dynamic memory, so we have to delete. And then just to be safe, we always want to make sure that we set pointers to null, like point to nothing, right? This is what this means, point to nothing. So simple concept: create memory, use memory, delete memory, nullify the pointer. But it's, in a perfect world, this would work. But I mean, we don't always know how long we will need the memory we create, right? So like a vector for the tic-tac-toe, we need it for the lifetime of our application. So that's why the recommendation to either work in functions, but probably a better recommendation is create memory in functions, okay, but a lot better in classes, because we can control the creation and deletion of memory with the constructor and with the destructor. And that's the example we'll start working on Wednesday. Okay, so circle is not a pointer, right? So if notice, like, circle is not a pointer. So what if we say, okay, so how do we do that? So shape pointer to a pointer equals new pointer to shape size, so 3 of them. So when this executes, we're telling the compiler that we have a pointer that points to a pointer, and we want to create memory for 3 guys, for 3 elements. So now we can say, okay, so shapes of 1, 0 equals new circle, and then this one can be a line, and then this one can be a line or a circle. It doesn't really matter. But now we can work with different objects, which is what we were after. And we can say shapes 1 at element 0 draw. Notice we have to use the arrow operator because now we are working with a pointer on the heap, right? And then I'll just do 1, 2. So now we will have 1, 2, 3, 4, 5, 6 draw circles, and then 7 draw circles, 1 draw line. Let's give line another chance, right? So we'll do line there. So 2 draw lines at the end, and then we can execute this one. And nobody told me, sir, you didn't get rid of memory. So I didn't, so we have to do that. But notice here, 1, 2, 3, 4, 5, 6, 7, and then 2 draw lines. And then we can say for integer I equals 0, I less than size plus I, shapes of I So we have to delete the memory in each element, and then at the end we have to make sure we delete that, and we just set it to null pointer to protect ourselves. That's a lot of stuff, right? How does this look in memory? We need this one. Okay. Pointer to pointer dynamic array of objects. And one more. This one. Okay, so we come here and we know we have the stack, and we know we have the heap. And stack, this should be easy. 3, that's the easiest one. And then we have shapes. And we'll use the same. Okay, so this one will point there, but what goes in here? So y70 goes here, but then what goes on the right side for y70? So it's a pointer to a pointer, so then a new circle is created. So a new circle is created. Let me 40, 30, 20, 10, 80, 90. Say C1 is created here, C2 and C3. So now we have y70 points to y30, y60 points to y90, and y50 points to y10. So oh, 30, wrong one, sorry, let me delete it. Okay, 30, 90, and 10. And that's how that would look on the stack, right? So notice that the diagrams get a little bit more complicated. Usually this is just for examples. The vector that we'll work with will look like this. I mean, there won't be objects, it'll be integers, right? So we're not going to work with something this complicated, but that's available in C++, as a pointer to a pointer to create dynamic memory on the heap, right? So questions here? So again, point to make here. What if, I mean, here we only have 3 lines of code after we create dynamic memory, and then we start deleting it. But in programs, that's not the case. Like, we're not gonna have perfect situations like this where we're kind of like, okay, I'm gonna create memory, I'm gonna use it, and I'm gonna get rid of it right away. That's usually not how it works. And point being is that vector in our tic-tac-toe. I mean, we need it for the whole application. So, and the same thing here. Like, we're not going to run into the situations that many times. So, starting on Wednesday, we'll start learning about class concepts to create dynamic memory using some C++ legacy rules, the rule of 3, and C++ 11 rules, the rule of 5, to understand how to create memory and make sure that we create, use, and delete without just getting memory and not releasing it, which creates a memory leak, or creating memory and have two pointers point to it and forget that, and then we have a situation where one pointer is pointing to invalid data. So we'll start talking about that on Wednesday. We'll go through a full example of a class to make sure that you all understand how to create dynamic memory in classes. That's all I have for today. So let me stop this. So